Okay, so in this challenge for the Class B game, we're going to create a basic dice game. And we're going to use object-oriented principles to do it. And we're also going to see the use of list comprehensions and generators, which are pretty handy. And lambdas as well, anonymous functions. Okay, so let's have a look at the code. So the challenge we're going to take on is setting up the basic dice game. So we're going to pull the previous tag so that we have not implemented that yet, right? So we're going to go git checkout, and we're going to take the E1 P1 M2 project setup, right? So second milestone project setup. I've done that already, so I won't run that. So that's our starting point, and then the challenge is design a dice game for a list of players. Each player has a name and a score. The game consists of a number of rounds, and in each round, the player rolls a dice, and the player or players with the highest score wins the round. And then the player or player who wins the highest number of rounds, of course, wins the game. Implement the game in Python. You can use the random module to simulate the dice roll, and then add a main function, so like if name equals main, to actually run the code to test it out. And then you should be able to create a game with, say, 3 players and 6 rounds, and print out the name of the winner at the end of the game, right? So that's the challenge. So I suppose an obvious place to create our dice game is going to be under games. So let's create a dice.py module here. Okay. And okay, and I'll just show you a few things about how I approached it. Um, if you haven't done it yourself, I'd say go off and give it a try, and then maybe come back and just have a look at it. And I'll just share a few notes from my own implementation and a few things that I think are useful and handy that you might enjoy. So in terms of the actual classes we want to create, we're going to need a die, definitely. We're going to need a cup to put the die in, and we're going to need a player, and we may as well have a game then to kind of orchestrate the gameplay. So that's one way of kind of designing our objects for this. There's other ways. We could have an umpire, for example. We could do without a game, and we could just allow a client to kind of construct a game, you know, and not really kind of worry about it in terms of our own implementation. Lots of ways of doing it, but this seems like a pretty good one, I think. So it'll be interesting to see like which way you choose yourself. So let's start with the die class. Um, so yeah, we're going to just hard code the number of sides to 6 for the moment. We can always take in number of sides if we have a multi-sided dice, and that could be something different than 6, right? And that is a possibility in a dice game. But for now, 6 is fine. And then really all we have to do with the dice is basically roll it. So we're going to use randint from the random in the standard library. So we want to return a number between 1 and 6 in this case, and that inclusive, which is important. We need to be able to roll a 1 or a 6, and that is the way randint works. And you can see it from its hint there. It includes both endpoints. That's exactly what we need. Okay, so we have our die, and then we need a cup to hold the dice. So what are we going to do here? Well, we're going to create a number of dice once we initialize a cup. And we're going to use a number of dice, and we're going to say, okay, let's create a new die for underscore in range num dice. So this is a list comprehension, and it's a really nice, concise way of achieving this. We could do it in a more verbose way, so we could do something like, for I in range num dice, and we could say, okay, we want to add a die to it. So we might start a list actually just above it. And we might say, okay, dice.append, so we'll append onto that list a die here. All right, so something like that. And that's fine as well, but the list comprehensions are really useful because like making your code concise to a point where it's still very readable and intuitive is great because it means that once you go through your code later, you can kind of see the high level flow of your code much more easily. Whereas if kind of very small things take three, four, 5 lines, your code is going to be 5 times as big, and it's much more difficult to maintain and to understand for yourself and other coders. So when you have a chance to do something concisely, and the implementation remains nice and clear, well then that's great. And this comprehensions are very standard now, so that's a nice way of doing it. Um, and then the other thing that the cup needs to do is to shake. So we're going to use a generator here, so very similar to the list comprehension. So we're going to say roll the die, die.roll for die in self.dice. So do it for every die in dice, and then we're going to sum up the results of each of those die.rolls. And this is lazy evaluation. So generators use lazy evaluation. So it doesn't need to, under the hood, kind of create a list of all those results first and then pass it to the sum. It's just kind of yielding them to the sum as they're being processed. So that kind of saves a bit of memory. So generators kind of similar to list comprehensions, but very useful for these kinds of functions. So that's the shake there. And then we get into the player class. So the player class is pretty handy then. We're going to maintain a round score and a game score, so that we can kind of keep track of who's winning rounds and then who's winning the game itself. And really all the turn needs to do then is to shake a cup, which will in turn, of course, um, sum up the die rolls that we just looked at. So you're going to get your results coming back from the roll through the shake into play turn, right? So that's kind of the way things are. It's kind of like the way the objects are being used in sequence. And so then the game is setting all that up and kind of orchestrating it. So we're going to take in the number of players, the number of dice, and the number of rounds we want to play in the game. We have another nice little list comprehension here. So player name for name and players. So we're going to create this list of player objects, and then the name of each of those has been set then at the start from the init. And then the cup is we're going to create just one cup that's going to be reused across the rounds, which kind of makes sense. And then the number of rounds is just an integer that's going to be passed in. So that's fine. And then we just start playing. So play self, well, we're going to say, okay, for each round and then for each player, we're going to go and play a turn, right? Play a turn with the cup. So that's fine. And we're going to hold that result in the round score for each player. All right, so we're going to hold it there. And we're going to have some nice prints here just to make it really clear what's happening when we run this. Then we're going to update the game scores, and then we're going to, at the very end, then declare a winner. So let's have a look at the game scores here. Sorry, the update scores first. So what we're doing here is we're going to say, okay, in this round, we're going to say the highest round score is the max of self.players. And then we're going to use this anonymous Lambda function here. And this is kind of handy because what max will do is it says, okay, we can get the max, of some attribute of these items, these players, and you tell us exactly what that attribute is, or rather, to be exact, what function are we going to use to extract that value that we're going to actually compare. So in this case, we're going to say for every P, we're going to go and get the round score for each of these players. And then that's what we're going to max. So what we're doing here is we're finding the player or players with the max scores here. And then we're going to get their round score out of that. Okay, so very nice. It's kind of similar to the idea that we've seen with the previous generator, except now we have this extra kind of cool thing where we have this anonymous Lambda function. And that saves, again, quite a bit of code, and it just makes things, kind of nice and clear. So just Lambda functions can be very, very useful that way. Okay, so we have our highest round score then, and then at that point we can say, okay, for all the player and players, if their round score equals the highest round score, well, they're a winner. So in this case, we're not worried about breaking ties. We're just saying, okay, anyone who has the highest score is a winner. We're going to print out their name. Okay, and then finally, and this is crucial, we're going to add one to their game score. So anyone who won a round gets a point. Okay, and then we're going to, at the very end, we're going to declare a winner. So we're going to say, very, very similar logic. We're going to say, okay, at the end of the game, we're going to get the max score, but this time we're going to use the game score. And then we're going to say, okay, if you have a game score equal the highest game score, well, you're a winner at the game level. So you might notice that there's a bit of an issue here because we're kind of breaking the dry principle in programming, the do not repeat yourself principle, where this code is very, very similar. So that's going to be, I think, a little challenge for the next milestone to see can we do better than that, and we'll do kind of a bunch of other things as well. But this is kind of a basic implementation of the game, and this should run okay. And so yeah, we see it here. So round one, round two, round three, we can see that we get Mike, and Anne winning the 3 rounds, and then Mike is the overall game winner. So if we go back to our challenge, well, we can do this with 3 players and 6 rounds. So, okay, we have 3 players here. Let's make it 6 rounds. Very easy to do. You can type because it's just a parameter. And let's go and run that. And you see the 6 rounds, and Anne is the winner here. So yeah, challenge done. And that's the code in. So, you'll probably want to commit this at some stage. You might want to kind of keep your own branch on this, so you can kind of go back on it. Yeah, that's it. Hope you learned something here. If you have any kind of like other ways you did things and things you learned, put them in the comments on the video. That would be fantastic. Thank you. Bye bye.